2018 Canadian Open Mathematics Challenge, Part A. Suppose x is a real number such that x times x plus 3 is 154. Determine the value of x plus 1 times x plus 2. So let's just solve this equation and then get a value for x, and then we'll plug it into this guy over here. Okay, so this is x squared plus 3x minus 154 is 0. And I believe this factors pretty nicely. So it'll be x for 11 and 14. And then let's see here, plus minus. Yeah, so that means x is either 11 or negative 14. Okay, let's now plug that into there. So if it's 11, it would be 11 plus 1 times 11 plus 2, which is 12 times 13, which is 156. If it's negative 14, it would be negative 14 plus 1 times negative 14 plus 2, which is negative 13 times negative 12, which is also 156. So I guess either way, the answer is 156. Let v, w, x, y, and z be 5 distinct integers such that 45 is equal to v times w times x times y times z. What is the sum of the integers? So 45 is equal to the product of 5 integers represented by these letters. And we gotta just fiddle around with this. So I fiddled around with it, and I thought, well, first of all, just break up 45. 45 is what? 3 times 5, right? But that's only 3 integers, and somehow, some way, I've got to get 5. So I thought, okay, well, why don't I just put in a 1 in there? That's perfectly valid, but I still only have 4 integers. And I thought, well, then what do I do now? I'm stumped. And I thought, well, I'll just put negative signs. So, for example, if you have a 1, you can put in a negative 1, right? That just changes the sign, but then you can make one of these negative. And I think that would be perfectly legitimate. A 1, a negative 1, a 3, a negative 3, and a 5. So you can assign these v, w, x, y, z. And I think the product will be positive 45. And therefore, those are the numbers. And what do they want? They want the sum. So basically, v plus w plus x plus y plus z. And in our case, it's going to be negative 1 plus 1 minus 3 plus 5. And that looks like 5. Points 0, 0, and 3, root 7, 7, root 3 are the endpoints of a diameter of circle symbol. Determine the other intercept of the other x-intercept of this symbol. Okay, so let's just draw a diagram. It doesn't have to be a work of art here. And then there's this circle. So first let's just label. We got 0, 0, and then something here. We got 3 root 7, 0. And then we have 7 root 3 will be up here somewhere, let's say. So this is our other point. And then there's a circle that kind of goes through. So something like this. And that circle has this point that they described, which is 3 root 7, 7 root 3. And it has the origin, which is down here. So those are on the circle. And then they tell us that the point that connects those two is the diameter. So let's just draw in the diameter. So that's going to be like that. And then finally, they're asking, what is the other x-intercept? So what is this point right here? Well, at first, it seems pretty obvious to me that it would just be 3 root 7, 0. That would be the point. But that seems a little too easy. Let me just see if I can explain it. Well, since that's a diameter, that red line that I drew, and we know that there's a rule, right? That if you draw a triangle within a semicircle, it's going to have a right angle. So if I draw this triangle, this one, that connects that point to the x-axis like that, then we know for a fact that that's going to be a right angle right there. That's just a property that if you draw a triangle within a semicircle, it will create a right angle. So that means that this line is perpendicular to that line, and therefore the point here would have the exact same x-coordinate as the point here. And that's why, for sure, it's 3 root 7. And then that point is on the x-axis, so its y-coordinate would be 0. So I guess that's about as much as I can say to show that the other x-intercept would be 3 root 7. In a sequence of positive integers starting with 2018, 1 to 1, 16, each term is the square of the sum of the digits of the previous term. What is the 2018th term of the sequence? Okay, first let's try to explain this. So we start off with 2018. The next term is the square of the sum of the digits. Okay, so first let's get the sum of the digits, which would be 2 plus 1 plus 8, and that is 12, or sorry, 11. I don't know how to add. And then you have to square it. So 11 squared, which is 121. So that's how they got that 121. Okay, let's do it again. The sum of the digits of 121 are 1 plus 2 plus 1, which is 4. And then now we have to square it. So that's 16. And that's how they got that 16. So that's sort of the process. Okay, let's keep going here. So 16, the sum of the digits is 1 plus 6, which is 7. Then we have to square it. So we get 49. Okay. Let's keep going here. So sum of the digits of 49 is 4 plus 9, which is 13. And then we square it, so we get 169. Sum of the digits of 169 are 1 plus 6 plus 9, which is 16. And then we square it, and we get 256. Okay, I'm trying to see if there's a pattern, but so far it doesn't seem to be. But let's keep going. 2 plus 5 plus 6, that is going to be 13. The square would be 169. Okay. Now 169, 1 plus 6 plus 9, that's 16. The square is 256. Oh, okay. Okay, I got it. So we're just going back and forth between 169 and 256 now. It's just going to repeat like that. Okay, so that makes it easy. So let's see here. This was the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term. So it looks to me that when it's an odd term, odd number, for example, the fifth term, the seventh term, after these guys, because these guys sort of don't fall into a pattern. But once we get over here, it looks like the odd number terms are 169. And then the even numbered terms, so 6, 8, and so on, are 256. So they want the 2018th term. And since 2018 is an even number, it would be 256. And that is the answer.